Good morning, students. Welcome to my class. And this is the chapter 3, atomic structure in chemistry. Atomic structure. This is the part 2. Okay, this last class I took this class. The proton here is a proton, 6 proton and 6 neutron and 6 electrons. So protons and neutrons is mass. Mass number is proton numbers plus neutron numbers. So 6 plus 6. So proton. So mass number is 6. Structure of the atom. Atom consists of 3 basic particles: protons, electrons, neutrons. The nucleus center of the atom contains the proton, positively charged, and the neutrons. So nucleus center of the atom contains 2 particles, one positive charged protons and another no charged neutrons. The outermost regions of the atom are called electron shell. It contains electrons. Electron is negatively charged. Proton symbol P, neutron symbol N, electron symbol E minus. Relative mass 1, proton, relative charge plus, position in the atom nucleus. Neutron symbol N, mass 1, relative charge 0, position in the nucleus. Electron symbol E and 1840th is the mass electron, and relative charge is -1, and position in the atom is the surrounding the nucleus, energy levels. Okay, which particles is the smallest mass? Which particle has the smallest mass? Proton, electron, neutron. Smallest mass? Electron. Achha, where the position of the proton in the atom?
In the nucleus.
Good. In the nucleus. Okay, proton, electron discovered J.J. Thomson in 1897, and proton discovered Rutherford 1911, and Chadwick discovered neutron in 1932. Okay, here is a 6 proton. This is the proton number. 6. Here is means protons. That means proton number means atomic number, and this the here is mass number. It is total sum of protons and neutrons. Here it is the mass number 2 atoms of carbon.
Huh? So you didn't share the screen.
Which things?
The screen, sir.
You are not watching.
You didn't share the screen.
I didn't share screen. I shared the screen.
Yes, sir.
Are you watching?
No, sir.
Hello, other sister. Are you watching my screen?
No, sir.
No.
Sir.
Who did this? Very bad. Now you may be watching my screen. Okay, now okay, here mass number, these 2 atoms, atomic, these 2 atoms of carbons, this carbon atomic number is 6, mass number is 12. This carbon atomic number is 6, mass number is 13. So here atomic number means proton number 6 6. So same proton number, different mass number, so they are called atomic number is the number of protons, and mass number is the number of protons plus number of neutrons. Okay, isotopes. Isotopes are atoms of the same element which have same atomic number but different mass number. Okay, we have seen these isotopes. Look, they have same atomic number but different mass number. So carbon 12 and carbon 13 are isotopes each others. Another carbon have 3 isotopes, carbon 12, 13, 14 also. Okay, isotopes are atoms of the same element which have the same atomic number but different mass number. They have same number of protons but different number of neutrons. Okay, I show now how different number of neutrons. Look, this is carbon 12, carbon 13, carbon 14. Carbon has 3 isotopes, carbon 12, carbon 13, carbon 14. So proton number is 6, proton number is 6, proton number is 6, but neutron number 12 minus 6, neutron number is 6. These atoms 13 minus 6, 7 neutrons, 14 minus 6, 8 neutrons. So we have seen here proton numbers are same but neutron number different, neutrons number 6, 7, 8. Okay, these things we have done already last classes. I am doing again. You'd say don't watch what I am erasing. Okay, this is the activity in this class. Okay, say how many proton number is chlorine 35? Protons number 17. Proton numbers or electron number are same in the atom, so electron number also 17. Okay, how much neutron number? Mass minus atomic protons. Huh? 18. Okay, good. Okay, so what is the proton number? Chlorine 35. Electron number 17. What is the neutron number? Huh? Newton's number 37. 37 minus 17. 20. Good. Okay, so idea, you take a screenshot to the attendance. Take a screenshot.
Okay, sir.
Screenshot take. Okay, this is the current page from current page. Okay, this is the isotope chlorine 35, proton numbers 17. Look, this is this chlorine 35, same proton number but neutron number is different. So chlorine 35 and chlorine 37 is isotopes each others. Next topic is Arya, have you taken screenshot?
Yes, sir.
Okay, thank you. Okay, look at a screen on the a single atom weigh hardly anything. For example, the mass of a single hydrogen atom is only about 0.00000000000000000000000000000000000 grams. Very tiny. It is hardly mass. Okay, so scientists had find the simpler way to express the mass of an atom. Here is what they did. First, they choose a carbon atom to be the standard atom. Look, this carbon atom mass is 12, atomic number is 6. Next, they fixed its mass as exactly 12 units. It has 6 protons and 6 neutrons, so mass 12. So it ignored electrons. Okay, here fixed mass is exactly 12 units. Okay, carbon fixed mass, they fixed its mass as exactly 12 units. Okay, next the scientist then they compared all other atoms with the standard atom carbon, carbon 12, using a machine called mass spectrometer, and found the value for their masses, other elements like this. This carbon, this is the standard of carbon 12 isotope, so its mass is exactly 12. And next, magnesium. This is the magnesium atom, is twice as heavy as the standard atom. So standard atom is 12, so it is twice, so 24. So magnesium mass is 24. Hydrogen, the hydrogen atom is 1/12 as the heavy as the standard atom, so its mass must be 1. So hydrogen mass is 1. So this mass, hydrogen mass 1 is not exactly the relative. Masses found in this way are called relative, since they are relative to the standard carbon atom. But not all atoms and elements are exactly same. Not all atoms and element are exactly the same. For example, when scientists examined chlorine in the mass spectrometer, they found there were two types of chlorine atom: chlorine 35, chlorine 37. Look, this is the chlorine. This is the chlorine 35. Its mass is 35, and here is chlorine. This mass, one of the atom has a mass of 37. So these atoms are the isotopes of chlorines. It was found that 75% of chlorine atoms have a mass of 35. Mass of 35, this chlorine atoms is it was found that 75%, and mass of 37 chlorine found 25%. So chlorine atom, so the average mass of chlorine atom was calculated 35.5. Next, so this is the relative atomic mass. Relative atomic mass, what is relative atomic mass? Is AR. It is expressed by AR. What is relative atomic mass? The relative atomic mass AR is the of an element is the average relative mass of its isotopes. So how do we find the average relative atomic mass of its isotopes? It was found that 75% of chlorine atoms have 75%. It was found that 75% of chlorine atoms have a mass of 35 and 25% of mass of 37. Calculate the relative atomic mass of chlorine. Okay, this, how can we calculate relative atomic mass of an element? We do percentage multiply mass of first isotopes and plus percentage mass of second isotopes, and so on. If three isotopes, will do percentage and mass of third isotopes. It's four isotopes given, you will plus and then percentage mass of fourth isotope, this way, so on. Have you understood how do we find the relative atomic mass? How do we calculate? Okay, say someone, if three isotopes percentage and mass given, how will do you calculate relative atomic mass?
Percentage into mass of first isotope.
Yes.
Percentage into mass of second isotope.
Huh?
Plus percentage into mass of third isotope.
Divided.
By 100.
Good. If three isotopes. Okay, thank you. So now we are going this question. This is the same question. It was found that 75% of chlorine atom have mass 35 and 25%. It was found that 75% of chlorine atoms have a mass of 35 and 25. এটা শব্দ করে কে? এটা মনোরো। Okay, this is the question. I take this question here. These things. This is. Okay, this is board. This have you seen my board here? Okay, now this is the question. My problem. It was found that 75% of chlorine atoms have mass of 35 and 25% have mass of 37. Calculate the relative atomic mass AR of chlorine. So I am doing this problem solving relative atomic mass of chlorine. Relative atomic mass AR of chlorine. Chlorine. That. Okay, here will be equal sign. Okay, this is here. You do these things, and at first we will write percentage. First isotope percentage is 75, and its mass is 35. There is a two isotopes. One isotope done. Now second isotope is 37, and percentage is 25. At first I will write percentage, and then I multiply its mass. Second isotope mass is 37 divided by 100. Have a calculator? Okay. So what is these things? Calculate 75 in 35. 75 into 35. This is 2625. Then plus 25 into 37. 25 into 37. This is 9. Are you calculating? Are you using calculator?
925.
Huh? Total?
35.5.
Okay. 35.5. 26. Okay, this is the 35.5. Okay, so this is the relative atomic mass of chlorine we have calculated. 35.5 chlorine atoms. Okay, you can calculate this way other elements. Okay, next topics. From this. Okay, we have just solved this problem. Now we are going to see some relative atomic mass of some element. Hydrogen 1, helium 4, carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24, aluminium 27, silicon 28, phosphorus 31, sulfur 32. Thank you for joining today's class. Okay, I'll give you a assignment here. Class finish. Next. Hello students. Are you listening?